$700 billion. That is roughly what Microsoft, Amazon, Alphabet, and Meta now expect to spend on capital projects in a single year. Not all of it is exclusively for AI. These budgets also include cloud infrastructure, buildings, networking equipment, and other long-term investments. But AI is the reason this number has become so large so quickly. And the obvious question is whether the technology works. The more important financial question is who gets paid first and who is still waiting for a return. Start with the scale. Amazon expects to spend roughly $200 billion in 2026. Microsoft is approaching $190 billion. Alphabet has guided to around $180 to $190 billion, and Meta expects between $125 and $145 billion. Use the midpoint of those ranges, and the combined total is roughly $710 billion. Again, that is total capital expenditure, not $710 billion spent only on AI chips. Still, it tells us how expensive the infrastructure race has become. For perspective, NVIDIA generated $81.6 billion of total revenue in its latest quarter. The annual capital budget of these four buyers is almost 9 NVIDIA quarters stacked on top of one another. That comparison is not an economic equivalence. Revenue and capital expenditure are different things. It is simply a way to understand the size of the number. And once the spending starts, some companies get paid much earlier than others. The money flows into processors, memory, networking, construction, cooling systems, and electricity. The companies supplying those things do not need to wait and see whether every AI assistant becomes profitable. They can recognize revenue while the infrastructure is being built. NVIDIA is the clearest example. Its latest quarterly data center revenue reached $75.2 billion, up 92% from a year earlier. Total quarterly revenue reached $81.6 billion, with a GAAP gross margin of 74.9%. Whatever happens to individual AI applications, the demand for the underlying hardware is already real. But the economics look very different for the companies buying that hardware. They spend the cash first, equipment gets delivered, data centers are installed, capacity goes online, customers begin using it, revenue may follow. Only after all of that can investors determine whether the return justified the original cost. That delay matters because not every asset lasts for the same amount of time. Microsoft has explained that roughly 2/3 of its recent capital spending went towards shorter-lived assets, mainly GPUs and CPUs. The remainder included longer-lived infrastructure that may support revenue for 15 years or more. A building can remain useful for decades. A high-end accelerator can become less competitive after only a few product cycles. So even if demand continues growing, part of this spending must be repeated. New chips arrive, older hardware becomes less efficient, energy costs continue, repairs, networking upgrades, and replacement spending do not disappear. That is why revenue growth by itself does not answer the main question. Amazon's AWS generated roughly $37.6 billion in quarterly sales, up 28% year over year. That is strong demand. But Amazon is also preparing to spend roughly $200 billion during the year across AI, chips, cloud infrastructure, robotics, and other investments. More usage creates revenue. It also consumes more compute. Alphabet faces a similar calculation. Cloud customers can pay directly for infrastructure. Search and advertising can benefit indirectly from better recommendations and more useful answers. Meta is even more dependent on indirect monetization, better recommendations, more engagement, more valuable ad impressions, and potentially higher advertising prices. These companies are making the same broad infrastructure bet, but they do not have the same path to earning the money back. Microsoft and Amazon can rent compute directly through Azure and AWS. Alphabet has a mixed model through cloud, search, and advertising. Meta primarily needs AI to improve the economics of its existing advertising business. That distinction is easy to miss. A user does not need to receive an invoice labeled AI for the investment to produce a return. If a recommendation system keeps people watching longer, improves advertising performance, or reduces operating costs, AI can still create economic value. But the required value is enormous. Here is a simplified illustration. Suppose $700 billion of invested capital needs to earn a 10% annual return. That implies $70 billion of annual profit. At a 25% after-tax margin, producing $70 billion of profit would require roughly $280 billion of annual revenue. This is not a forecast. It ignores timing, depreciation, financing, taxes, different asset lives, and the fact that existing cloud and advertising businesses share this infrastructure. The point is not that $280 billion is the correct target. The point is that a project can be useful, popular, and technically impressive, and still fail to earn an adequate return on the money invested. There is a reasonable bullish case. Demand for compute remains strong. Cloud backlogs are growing. AI products are improving quickly. Higher utilization spreads fixed costs across more customers. Better software and custom chips can reduce the cost of each useful result. If these systems become part of everyday business, today's infrastructure may look less like speculative excess and more like the early build-out of the internet. But the risk case is just as real. Model prices are falling. Competitors are aggressive. Hardware depreciates. Energy is expensive. New generations of chips can make previous purchases less attractive, and companies may discover that customers love AI features but do not want to pay enough for them. The internet changed the world. It also destroyed a great deal of investor capital along the way. Both things can be true again. My view is that this is not simply an empty bubble. The demand for compute is real, and some of this infrastructure will support valuable businesses for many years. But the returns will not be distributed evenly. The suppliers can book revenue during the build-out. Big tech must keep the capacity busy, defend pricing, control replacement costs, and eventually produce enough profit to justify the bill. That is the real $700 billion bet. The model can generate the answer. The bill still comes due. And in the end, AI does not only need to work. It needs to earn its cost of capital.